Sir, Gurvinder sir, you may start the session, sir.
Okay, thank you, sir. Hi,
Thank you.
hello everyone. Till yesterday, we were discussing about tangents and normals. So just one last question before we move on to the next topic. So over here, you can see the question. So it is given that tau is any curve y as a function of x. Okay, y is equal to y of x. So that means y is a function of x, which is in the first quadrant. Okay, so you have got any random curve, something like this, or you can just treat it any random curve. What it is saying is, and the point 1 comma 0 lies on it. Okay, so it is telling me that the tangent to this curve at any point p. Okay, so if I assume this point p as some point x naught comma y naught that lies on this curve, if I plot a tangent at x naught comma y naught, okay, if I plot a tangent at this point p, okay, so it intersects the y-axis. So I have got this y-axis over here. This is x, this is y. It intersects the y-axis at a point named as yp. Okay. It is telling me that the length, the distance between p and yp, the length p yp is always equal to 1. So it is asking me to find out the differential equation, to find out the equation of this function y of x. So let us give it a try how we can do it. So first of all, can you tell me what will be the tangent? What will be the slope of the tangent? Slope of tangent? Anyone? If I plot a tangent to this curve y of x, what will be the slope of tangent? Will it be equal to dy by dx? Is this right? Right? Tangent to the slope. Slope of tangent is dy by dx. Right, everyone? Okay.
Yes, sir.
Yes, sir.
So,
Yes,
and
sir.
I already know a point. I already know a point that lies on this line. The point is x naught comma y naught. So I know the slope of the line is dy by dx, and I know that the point is x naught comma y naught. Can I write down the equation of tangent? Is that possible? Can anyone just tell me what will be the equation of tangent? Bhavna, Gayatri, can you tell me? I know that the point is x naught comma y naught, and I know that the slope of tangent is dy by dx. So what will be the equation of tangent?
Y minus Y naught
Great.
M into
Into, okay.
dy
X
by
minus X.
No, sir. Is equals to slope into
dy by dx into
Hmm.
x minus
Into,
x.
great.
x
Right,
minus
this is correct.
sir.
Because y minus y naught is equal to m times of x minus x naught. That is the standard equation, right?
Yes.
Yes, sir.
Okay, great. So this is the equation of the tangent. Now I need to calculate where my tangent is intersecting the y-axis. Is it possible for me to calculate? Can you tell me what will be the x coordinate at that point? What will be the x coordinate when it is intersecting the y-axis? If my line is intersecting the y-axis,
0.
yes, great. So x is equal to 0. If I substitute x is equal to 0 in this equation of tangent, can I say the value of y will be my y coordinate of yp? Can I say that? Right? It will be correct, right?
Yes,
So
sir.
can you tell me what will be the value of y? Y will be y naught minus dy by dx into x naught, right? So can you tell me what will be my coordinates of yp? My coordinates of yp. What are my coordinates of yp? Anyone? What is my x coordinate of yp? First of all, what is my yp? Yp means where this tangent is intersecting the y-axis. So can you tell me what will be the x coordinate of yp?
0, sir.
0,
Great. And what about the y coordinate? We have calculated this, right?
Not
y
minus
naught minus dy by dx
x naught.
of
Into x naught. Great. Correct. So can you?
Yes.
So this is my point yp, and I know my point p. My point p is x naught comma y naught. Can I calculate the distance between both of them? Can I calculate p by p? The
Yes.
distance between both of them. So how much will that be? It will be square root of x naught square plus this thing minus this thing, right? I'm subtracting the coordinates. I can just easily subtract the coordinates, right? So that is what I'm doing.
Yes, sir.
So
dy
tell
by
me.
dx
So
in
Into
dy
x
by
naught.
dx
whole square.
x into x naught whole square, right?
Yes,
Correct.
sir.
Yes, sir.
Is the value of p by p known to me? Is the value of p by p known to me?
1.
1, sir.
1. If I square on both sides, I can do that, right? I can square on both sides. So
Yes.
x naught square plus dy by dx into whole square into x naught square is equal to 1. Right? Is this
Yes,
right?
sir.
Right? Okay. So what is my value of dy by dx? So dy by dx whole square is equal to 1 minus x naught square divided by x naught
X
square.
naught.
Correct? Correct?
Yes, sir.
Yes, sir.
So my differential equation, if I write this as a differential equation, dy by dx is equal to dy by dx is equal to square root of 1 minus x square divided by x. Right? This will be my differential equation because I had calculated my dy by dx to be the value of slope at some particular value x is equal to x naught. So basically this dy by dx was at some particular value x is equal to x naught. So I can just replace this x naught with any random value x. So I will get this as my final differential equation. Right, everyone? Dy by dx is equal to square root of 1 minus x square whole divided by x square. Right?
Yes.
Okay, great. So this was all about the question. Like, even though it had one more part, but actually, we have a method by which we can solve this thing. By integrating both sides. But that we will be learning in differential equations. When we will learn about differential equations, then we will be solving it. So, okay, so this was it because all you needed to do was just get to the differential equation. And after we study differential equations, we will be able to solve it. And this was a question PYQ from J Advanced 2019. Okay, so this was the differential equation. And obviously by integration, you can solve it and get the final value of what is the function of x. So that is not currently covered, so you can do it later. Okay, great. So today using differentiation, we'll be talking about increasing and decreasing functions. Even though we have discussed it earlier, I hope all of you remember. When we were doing the common syllabus to both JEE and NEET students. So during that time, we had discussed about increasing and decreasing functions. So for example, you have got a function y is equal to f of x. You differentiate it, you get f dash x. F dash x denotes slope of tangent, right? It denotes slope of tangent. So obviously you can just guess it directly. Slope of tangent means, for example, this is your x-axis. So you have got only two possibilities, or rather say you have got only three possibilities. Okay, so this is your angle theta 1. So over here, this is your angle theta. So instead of calling it theta 1, I can just directly call it theta, theta, and theta. And again, this is angle theta. Can you tell me what will be the slope in this case? slope will be positive. In this case, slope is negative. And in this case, what is the slope? What is the slope in the third case? This is my x-axis, okay? This is my
Equal to
x-axis. Yes, slope is equal to 0. Great. Because it is a line that's parallel to the x-axis. We have got one more case also. If this is my x-axis and I have got a line that's perpendicular to it. So what will be the slope? What will be the slope in this case? It will be not defined, right?
Yes, sir, not defined.
Yeah. So I hope all of you now understand the clear difference between not defined and infinity. All of you understand it? What is the difference between not defined and infinity? So if I am giving you a line that's perpendicular to your x-axis, so it will not be infinity, right? We have discussed it in limits. I hope all of you. Right? So you can just directly see in the first case, when your slope is positive, if you keep on increasing your value of x, your value of y is also increasing. So I can say in such a case, when your dy by dx or slope of the tangent is positive, okay, if your slope of the tangent is positive, we call that at that particular point, your function is increasing. Okay, increasing function. The function is increasing at that point. Similarly, you can see if you've got a negative slope, if you keep on increasing your value of x, your y keeps on going down. Okay, so it is decreasing,
Decrease.
right? It is decreasing. Over here, what is happening? It is constant. No matter what you keep your value of x, it is constant. Over here, you can't say anything because your function is only defined for one particular value. Okay, so like you can't say anything because the slope is not defined. Fine. So you have got three cases: increasing, decreasing, and constant. So whenever your dy by dx is positive, you say that the function is increasing because your slope is positive. So as you move your x towards your right side, okay, so as the x increases, your value of y also increases. Over here, what happens? You increase your value of x and your value of y keeps on decreasing. Over here, you keep increasing your value of x, your y doesn't change. It is constant. Okay. So over here, your dy by dx is negative. Over here, your dy by dx is equal to c. Fine. So let us discuss about a few functions and how about their increasing or decreasing, about how they are increasing or decreasing. So for example, I give you a function y is equal to 7x minus 3. And I'm asking you, can you tell me what is the value of dy by dx? Value of dy by dx is 7,
7.
right? So dy by dx is always greater than 0 for all values of x, right? So what can I infer about this function? Can I say it is always increasing?
Yes, sir.
Yes, sir.
Okay, it's always increasing, correct. Can you tell me what is the value of dy by dx? E raised to 2x.
E raised to
Yeah. Hmm.
2x
E raised to 2x
into 2,
into,
sir.
yes, great. So I can write it as 2 e raised to 2x. So if all
Yes.
of you remember, can e raised to 2x be a negative value ever? Is that possible? E raised to 2x, e raised to x in general. E raised to x is always positive. I hope all of you remember
Yes.
relations and functions,
Yes, sir.
right? E raised to x is always a positive value. So e raised to 2x will always also be a positive value. So dy by dx is always greater than 0. So the function is always increasing. Okay. Function is always increasing. Okay. Let us discuss a few more cases. Okay. So let's get to a complication. Let us give it a try. So fast. What is the value of dy by dx?
2x plus
2x
2x minus 4.
X minus 4.
2x minus 4. I can write it as 2 into x minus 2. Okay.
Yes, sir.
Can you tell me where the function is increasing and where it is decreasing? X minus 2. So at what value of x is my dy by dx 0, first of all? Can you tell me? When is dy by dx 0?
X equal to 2.
X is equal to 2. Okay. So at x is equal to 2, dy by dx is 0. Okay.
Yes, sir.
If x is lesser than 2, is my dy by dx negative or positive?
Negative.
If great, it is negative. Correct. What about this? When x is greater than 2, my y dash is greater or lesser than 0?
Positive.
Greater.
Greater than
Positive,
0.
right?
0.
So when x is negative, it is decreasing, right? It is decreasing. And when it is x is greater than 2, it is increasing. So my graph will be something like this. Like I don't know how the graph will be, but I can surely say that it will come down. It have its minimum value because from till 2 it is decreasing. After 2 it is going up. So it will be something like this, right? I can just infer something like this. Fine. Let us increase our degree by 1 and have a look. So you have been given y is equal to x cube minus 3x square plus 4x. So what is the derivative?
3x square minus 6x plus 4.
Plus 4.
3x square minus 6x plus 4. Great. So I can write it as, just for your reference, I can write it as 3 into x minus 1 whole square plus 1. Can you infer anything from here about your value of y dash? See, x minus 1 whole square is always a positive or equal to value, right? Either it is equal to or greater than 0. Right, everyone?
Yes, sir.
Right? So your y dash will also be always greater than 0. Can I say that? Because it is 3 times of x minus 1 whole square plus 1. Can I say that y dash is always greater than
Yes,
0?
sir.
Right? So it is always increasing.
Yes, sir.
Okay. Great. Let us move into trigonometry and see. So you have got y is equal to cos x. Just a minute. So what is the derivative?
Minus sin x.
Minus sin
Great,
x.
minus sin x.
Minus.
And you just need to discuss about the increasing and decreasing between 0 and 2 pi. Okay. Between 0 and 2 pi. Let us have a look. So dy by dx is minus of sin x. So sin x, let us see how sin x goes. So sin x goes like 0, 0, 1, and minus 1, right? So minus of sin x. So in the first quadrant, is my sign positive or negative? In my first quadrant, is my sign positive or negative? Sign is positive. Great. What about second quadrant?
Positive, sir.
Positive.
Third,
Positive.
third,
Negative,
third
sir.
is negative. And over here also negative. So
Yes,
what can
sir.
you infer
Negative.
about dy by dx, right? See, dy by dx is minus of sin x. Okay. So if I input my sin x as a positive value, it will invert that. And if I input my sin x as a negative value, it will give me a positive value. So can you tell me dy by dx? Can you infer anything about dy by dx? First quadrant, second quadrant, third quadrant, and fourth quadrant? Tell me, in my first quadrant, will my dy by dx is positive or negative value?
Negative y.
Yes, sir.
Negative. It will be negative. Great. What about second,
Negative.
Negative.
third,
Positive.
Positive, sir. Fourth
fourth
also.
also positive?
Yes, sir.
Great. So what is happening is in the first two quadrants, So can you tell me in the first two quadrants, what is the range of angle? What is the value of angle? It is 0 to pi.
0 to pi.
Okay. So between 0 to pi, it is increasing or decreasing? Is my function increasing or decreasing?
Decreasing.
Decreasing.
Great. It is decreasing. Correct. So, and between 3 and 4, what is my angle? Pi and 2 pi, right?
Yes, sir.
And from pi to 2 pi, it is increasing. Correct?
Yes, sir.
Okay, great. Great. So let us do one more question. So y is being given to you as x square minus 4x plus 6. Okay. So it is asking you, and obviously x is valid for all real numbers. So it is asking you to find the interval in which function is increasing and and in which it is decreasing. Can you tell me what is the value of dy by dx? So it is
2x
how much?
2x minus 4.
X
2x
minus
minus 4. So I can write it as 2 into x minus 2.
Yes,
2
sir.
into x minus 2 again. So like I can just directly do it, like without even thinking any, like without even going much into the detail. Can you tell me what is where it will be greater than 0 and where it will be lesser than 0? Anyone? We have just done this question, similar question just over here. So tell me.
When x is greater than 2, it will be increasing. When x is less than 2,
Okay, correct. So when x is greater than 2, it will be increasing. And when x is lesser than 2, it will be decreasing. Correct.
Yes.
Right? It was really easy. Okay, so now let us give. See, in quadratic cases, it is really easy to guess. Okay, in quadratic equations, it is really easy to think where it will increase and where it will decrease. Because when you differentiate a quadratic equation, you get a linear equation. Linear equations are really easy to think of. Fine. So this one was really easy. So that is why now y is given to you as 4x cube minus 6x square minus 72x plus 30. And it is again asking you the intervals in which this function is increasing and in which it is decreasing. So value of dy by dx is what?
12x square minus
12x
12x
X
minus 72 plus 0.
Okay. So this is it.
Yes, sir.
Can I? So if I take 12 common from this, so it will be x square minus x minus 6. Correct? Can we factorize it?
Yes, sir.
Can you factorize? So I can write it as 12 into x minus 3 into x plus 2. Okay. 12 into x minus 3 into x plus 2. Now, your dy by dx value is given to you as 12 into x minus 3 into x plus 2. Is there any method by which we know in what
Sir,
range it is?
minus 3.
Oh, sorry. Yeah, x minus 3. Yeah. So I've got x minus 3 into x plus 2. Is there any method till now which we have learned by which I can guess in which interval this thing is positive and in which interval it is negative? Do we have we done something in the first chapter, if you remember? The first chapter of set theory that we had done. I hope all of you remember wavy curvy method. Everyone forgot?
No, sir.
Okay, you remember. So tell me, what are the points? Wavy curvy method, what are the points of this?
Sir, not there in that class. We are
Okay.
new.
Oh, okay. Anyone? I guess just a minute. Gayatri was there, right?
Yes, sir.
Do you remember?
Yes, sir.
Great. Can you tell me? So see, like what we do is when we separate out these terms, so we equate all of these terms, these singular brackets equate to zero. Okay. We equate these brackets to zero. After doing that, whatever is the value of x, that are my points. So first point is 3 and second point is -2.
-2.
Okay. Then what I do is I start from the rightmost side. Starting from the rightmost side, I see that outside this brackets, is my sign positive or negative? Okay, is my sign positive or negative? So over here, my sign is positive. So I start from the rightmost side as plus, then alternating signs. So plus, minus, and plus. Okay, so just in case who were not there, I would just take 5 minutes in explaining wavy curvy method. So what happens in wavy curvy method? What we had done is, for example, you have got your y, okay, as something like x minus 2, x plus 3, x minus 4, okay, whole divide by x minus 5, x minus 6, x plus 10, something like this. Okay. And you need to check what are the intervals. Okay. So obviously this function is valid for all real numbers except for 5, 6, and -10. So you need to tell me what are the intervals on the number line. Okay. So this is my number line. You need to tell me what are the intervals on this number line wherein this function, the value of this function is positive and where it is negative. Okay. So what you do is you write this in form of these brackets. After that, what you do is you find out the points, you equate all of these brackets to zero, and you find out all the points. So the first point will be 2, second will be -3, then I have
-3,
got 4,
4.
right?
4
Then I've got 5, I've got 6, and I've got -10.
-10.
Okay. These are my points. Correct. After that, what you do is you don't look at these brackets, you look outside this. So outside these brackets, have I got a negative term or a positive term? Over here, I have got 1. 1 is a
First.
positive number, right? Okay.
Yeah.
So I start from the rightmost side. I start from the rightmost side with a plus. Then I do alternating signs. So plus, I have written as a plus in the rightmost side. So plus, then a minus, then a plus, then a minus, then a plus, then a minus, and then a plus. So I hope all of you know what this means. So it means that between -10 and -3, y will be a negative value. Between -3 and 2, it will be a positive value. Between 2 and 4, it is a negative value. Then between 4 and 5, a positive value. Between 5 and 6, it is a negative value. From 6 to infinity, it is a positive value. And similarly, from -infinity to -10, it is again a positive value. This is what it symbolizes. Okay. So, for example, you had this similar case. So just a minute. I'll just copy this case down. So for example, you have this case, but in this case, in a few terms, you have got a square and a raised to 4th power. Okay. So what you do is, see, you always know that x square is always positive. Okay. So you ignore those terms which has even power. Right? Why you ignore those terms which have even power? Because, like, for example, you have got something like this. So obviously, you know, x plus 3 whole square will always be positive. Similarly, x plus 10 whole raised to 4, it will always remain positive. So you don't need to count this. So you can just directly come down and forget about all those terms which have squares. So you get it as x minus 2 into x minus 4 divided by x minus 5 into x minus 6. Okay. So now you equate, you just operate on all of them. So can you tell me what will be my points?
2,
2,
4,
4, 5, 6.
Great. 2, 4, 5, 6. And okay, so just for little bit complexity, I'll include a -3 over here. Okay, -3. So I should start from the rightmost side. Okay. So the right of 6. So should I include a minus sign to the right of 6 or a plus sign?
Minus.
Right? I should include a minus sign. Correct. I should include a minus sign. Absolutely correct. So between 5 and 6, what sign?
Positive.
Yes,
Okay,
sir.
what about this? 4 and 5?
Minus.
Yes, sir.
Okay, then a plus and then a minus. And you can
Yes.
actually manually verify your answers if you wish to. Okay. You can actually check your answer if you wish to. It will always be in this form. And we had discussed the reason for this in set theory chapter. So like, I'm not sure who many were, all of you were present there, but so we had discussed this, how we are operating this thing with a detailed proof of this. So just in case if you need a proof, you can go back. So what we do is we ignore our even power terms. Okay. We ignore our even power terms, and all the odd power terms, we take the points, we check out the sign, start from the rightmost side and do it. Okay. So just for example, okay, for example, you have been given that the dy by dx of a function is being written something like this. So it's written as -3 into 2x minus 7 whole raised to 5 into 3x minus 2 whole square into x plus 8 raised to 101 whole divided by uh, x minus 11 raised to 2001 into 3x minus, okay, let us take it 3x minus 10 or 3x minus 31, okay, raised to 101. Okay, so that's it. And now I'm asking you where the function is increasing and where it is decreasing. Okay, so what will be your first step? The first step you will be taking is ignore all the even power terms. Okay, you will be ignoring all your even power terms. So you'll write it as -3 into 2x minus 7 raised to 5, okay, into 3x minus 2 whole square will get ignored into x plus 8 raised to 101 divide by x minus 11 raised to 2001 into 3x minus 31 raised to 10. So can you just tell me what will be the points? What will be the important points?
7 by 2.
2.
8. 11. 31
7
by
by 2 minus 8. Okay, then I've got 11 and I've got 31 by 3, right? 31 by 3.
Yes, sir.
Will it look something like this? Okay.
Yes, sir.
So I start from the right hand side to 11. Okay. I'll start from the right hand side to 11. Will it be a
Negative.
positive or negative sign?
Negative, sir.
Negative sign? Okay, great. What about between 31 by 3 and 11?
Positive.
Positive.
What about this?
Negative.
Negative.
Okay, what about this?
Positive.
Positive.
And to the left of -8?
Negative.
Great. So you have calculated where your dy by dx values are positive and negative. So now can you tell me in what intervals will my function y of x be increasing and decreasing? Can you tell me? What will be those intervals where my function will be increasing or decreasing?
-8 to 7 by 2.
-8 to 7 by 2. Will it increase or decrease?
Increase, sir.
Okay, increase. What about this 7 by 2 to 31 by 3?
Decrease, sir.
Great. What about this? It will increase. And
Increase.
from 11 to infinity, it will again decrease. Okay. Similarly, from -infinity to -8, it will decrease. Okay. So it will act something like this. Great. Clear,
Yes,
all
sir.
of you?
Yes, sir.
Okay. Okay, great. Okay. So you have been given your function y as sine of 3x. Okay. Sine of 3x. And x belongs from 0 to pi by 2. Okay, 0 to pi by 2. So obviously it is asking you to calculate, to find those intervals where it is increasing and where it is decreasing. Can you tell me what will be the value of dy by dx?
Cos
Of
3x.
3x
Cos of 3x?
6
into 3.
Okay,
into
so 3 cos 3x. Right, I can write it as 3 cos 3x.
Yes, sir.
Correct? Okay. So 3 into cos of 3x. So in order to check where cos of 3x, how cos of 3x is working. If x is going from 0 to pi by 2, so 3x will go from 0 to 3 pi by 2. Cos. So how does cos work? So it will work like 0, 0, 1 and minus 1. Right? 3x. I've just treated my 3x as a new quantity. So you can just think of 3x as some quantity z. So 3 cos of z. You can see it as 3 cos of z. Okay. So this is my z, cos of z. So in my first quadrant, is it positive or negative?
positive, sir.
Positive, sir.
Positive, sir.
What about second,
Negative.
Negative, sir.
third,
Negative, sir.
Negative.
and over
Positive.
here positive?
Positive.
Great, correct. Right? So can you tell me what are, so it is talking between 0 to pi by 2. And z is just between 0 to 3 pi by 2. Z is between 0 to 3 pi by 2. So 0 to 3 pi by 2 means this thing. Okay. So first, second, and third quadrants only. Only first, second, and third quadrants. So can you tell me? So when z is belonging from 0 to pi by 2, is my dy by dx positive or negative?
Positive, sir.
Positive,
Okay, so
sir.
it is increasing. Great. And between pi by 2 to 3 pi by 2, it is negative. So obviously it will be decreasing. Correct?
Yes, sir.
Okay. So again, I'll just keep my z back as 3x. I'll again keep back as 3x. So can you tell me what is the range of x? What is the interval of x? If 3x is between 0 and pi by 2, where is x? I just divide this by 3. So it will be 0 and pi by 6. The same way over here, it will be pi by 6 to 3 pi by 6. 3 pi by 6 is also pi by 2. So what is happening is between 0 and pi by 6, between 0 and pi by 6, my function is increasing. And between pi by 6 and pi by 2, my function is decreasing. Correct, everyone? Got it? Any doubt, anyone? Any doubts? See, like how this 3x and this 3 got divided. So like whenever you have a linear function, okay, with a positive constant, you can just directly replace and divide both of these. So it is something like if 2x belongs from 0 to 2. So obviously you can say that your x is between 0 and 1. If your x is between 0 and 1, that is how your 2x will be between 0 and 2. Okay. So even though we have done it and used it many times in our set theory chapter also. Okay. This was just a revision of this. Okay. So a function is being given to me. Function is y is equal to ln of 1 plus x. Okay. Minus 2x by 1 plus x. Obviously, x is greater than minus 1. If x is not greater than minus 1, then ln of 1 plus x. So 1 plus x will be a negative value. So it won't work. Natural log does not exist of negative values. So you need to prove that this function y is increasing in its whole domain. Let us see. Can you tell me what is the derivative of ln of 1 plus x? ln of 1 plus x. What is the derivative?
1 by 1 plus
1 by 1 plus x.
Into 1, sir.
Okay, so into 1 means that is okay. So it will be just like that because into 1 means the same thing, right? Minus 2 times. Now you have got x divided by x plus 1. How will you differentiate x divided by x plus 1?
Division rule.
rule.
Great, division rule. So you differentiate the top, keep the bottom as it is, minus. Keep the top as it is, differentiate the bottom, divide by bottom square. Okay. So it turns out to be 1 by 1 plus x minus 2 into 1 plus x minus x. So it can just be like this, 1 plus x whole square. Okay. So can I do something about it? So obviously I can multiply it by 1 plus x. So it becomes 1 plus x minus 2 whole divided by 1 plus x whole square. Okay. So it becomes x minus 1 divided by x plus 1 whole square. Is this correct?
Yes, sir.
Okay. Just a minute. So x minus 1 divided by okay, just a minute. It was 2 plus x, not 1 plus x. Now, can we just do it again? Is that possible? So in place of this, I just need to keep this 2 plus x. Okay, so it's 2 plus x. So 2 into x by 2 plus x. So uh, differentiation of top into bottom as it is minus x into 1 whole divided by 2 plus x whole square. Okay, great. So 1 by 1 plus x minus, what does it become? What does the second part become? So it is 2 times of x plus 2 minus x. So it becomes 2 by 2 plus x whole square. Okay. So it is 1 by x plus 1 minus 4 by x plus 2 whole square. Okay. This one is a really, really good question. Like, can you prove how this thing will always be positive? Is it possible for us to prove how this thing will be positive? Can you think? So obviously my tactic would be for it to somewhere to get into wavy-curvy method. So for that, I will need a common denominator and a common numerator. So what I'll do is I'll send this thing up. So it will be x plus 2 whole square minus 4 times of x plus 1 whole divided by x plus 1 into x plus 2 whole square. Okay. So x plus 2 whole square can be written as x square plus 4 plus 4x. Okay. Minus 4x and a minus 4 whole divided by x plus 1 into x plus 2 whole square. So this 4x gets cancelled. This gets cancelled. So my value of dy by dx turns out to be x square divided by x plus 1 into x plus 2 whole square. So I need to check what is the interval at which my dy by dx is positive and where it is negative. So obviously it is a form of wavy curvy method. All of you can see it is a method of wavy curvy, right? So if I apply wavy curvy method and I need to check where it is positive and where it is negative, what can I do? First thing should be to ignore all even powers. If I ignore all even powers, I will just be left with 1 by x plus 1. My critical point will be minus 1. Do you all agree?
Yes, sir.
Right. To the right of this, will it be positive or negative?
Positive, sir.
And what about the left? It will be negative,
Negative.
right? So I can say that when x is lesser than minus 1, my dy by dx is negative. And when x is greater than minus 1, my dy by dx is positive. If dy by dx is negative, so it is decreasing. And when dy by dx is positive, it's increasing, right? When dy by dx is negative, it is decreasing. And when dy by dx is positive, it is increasing. But I am only talking about, see, I have restricted my domain. My domain is only x greater than -1. So this is only my domain. So in my whole domain, can I say that my function is increasing?
Yes, sir.
See, because my domain was only x greater than -1. And when my x is greater than -1, my dy by dx is positive. So I can say that in my whole domain, my function is only increasing. Right? Okay. Correct. So I have got my function y as x into x minus 2 whole square. Okay. So it is asking you, what is the range? What is the interval where this function is increasing and where this function is decreasing? Fine. Let us give it a try. So how will you differentiate this thing? How will you differentiate this? It is basically x square minus 2x whole square. So how will you differentiate this thing? Anyone? Basic chain rule, right? Okay, so tell me the derivative. What is the derivative of this thing?
2x square.
2x square.
2 into
2
x
into,
minus 2x
okay,
into
into,
2x minus 2.
correct, 2x minus 2. So if I just take out x common from this, so I can write it as 2 into x into, so x minus 2 into, I can take out 2 common from this, and I can write it as x minus 1. So it looks something like 4 into x minus 1 into x minus 2. Okay. So I need to check what are those intervals wherein my dy by dx is positive and negative. So again, I should go and apply a wavy curvy method. So can you tell me what will be my points? What will be my
0, 1,
initial
2.
points? Okay. To the right side of 2, is it positive or negative?
Positive.
Positive.
It's positive. Great. Between 1 and 2,
Negative.
Sir.
what about 0 and 1?
Positive.
What about minus infinity to 0?
Negative, sir.
Negative.
Correct. So from minus infinity to 0, is my function increasing or decreasing?
Decreasing, sir.
What about 0 and 1?
Increase.
Increasing, right? Between 1 and 2, decreasing.
It's
And between, again increasing, right? So from minus infinity to 0, it is decreasing. From 0 to 1, it is increasing. From 1 to 2, again decreasing. And from 2 to infinity, again increasing. Okay, great. So you have got your function y. Obviously, it is sin x, 4 sin x divided by 2 plus cos x minus x. Okay. And x is only between 0 and pi by 2. So you need to tell where it is increasing and where it is decreasing. So how will you differentiate this thing? How will you differentiate this? Division rule. Correct. Division rule, right? So it's
cos x plus
into
cos
2 plus cos x. Okay. Minus
sin x.
into minus sin x. Correct.
Yes, sir.
Whole divided by 2 plus cos x whole square. Okay.
Square.
And then a minus 1. Let us have a look at it. So it's 4 into 2 cos x plus cos square x plus sin square x. What is cos square x plus sin square x?
1.
Sir.
Okay, correct. Whole by 2 plus cos x whole square. And then a minus 1. So it is something like 4 into 1 plus 2 cos x whole divided by 2 plus cos x whole square and then a minus 1. Is this correct?
Yes, sir.
Everyone? Okay, it's correct. Can you infer anything about this? See, okay, so I'm not very sure, but we have done it in relations and functions. I don't know if you are revised with that or not. So, like you can just directly see that 2 plus cos x whole square is always a positive value, right? 2 plus cos x whole square is always a positive value. Can you tell me between 0 and pi by 2, where does cos x belong to? Between 0 and pi by 2. See, x is being restricted between 0 and pi by 2. So where does my value of cos x go from? If x is between 0 and pi by 2, where does cos x lie? Anyone? It is between 0 and 1, right? See, in the first quadrant, okay, in the first quadrant, between 0 and pi by 2, your cos x lies between 0 and 1. So 2 times of cos x, 2 times of cos x will lie between 0 and 2. And you add 1 in that. So 1 plus 2 times of cos x. It will lie between 1 and 3. Right? Between 1 and 3. Into 4, right? Because it is 4 times of 1 plus 2 cos x. So it will be between 4 and 12. It will be between 4 and 12. All of you agree?
Yes, sir.
And then you have got a minus 1 on this side. So obviously I can directly say that my dy by dx will always be a positive value. Right? My value of dy by dx will always be positive. So if my dy by dx is positive, what can I infer?
Increasing.
Increasing.
Okay. Correct. Great. So just a okay. So you have got a function y as x raised to 100. Okay. Plus sin x minus 1. Okay. And first is 0 to 1. Second is pi by 2 to pi. And third is 0 to pi by 2. And D is none of the above. So you need to tell in which of these intervals is your function y decreasing. Okay. So only decreasing. Like in the whole interval, it should be only decreasing. So can you tell me what will be the value of dy by dx?
100 into x raised to 99 plus
99 plus
cos x.
cos x. Okay, correct. So let us have a look between all of them. So if you look at the first interval, in your first interval, it is 0 to 1. So between 0 and 1, both your x raised to 99 and cos x just. So in the first option that's been given to you, the first option is 0 to 1. So between 0 and 1, what is happening? Between 0 and 1, both x raised to 99 and cos x both have positive values. So your dy by dx will be positive, right? Because both of them are positive. 0 to 1, x raised to 99 is also positive and cos x is also positive. So obviously it will be positive value. Let us have a look at pi by 2 to pi. So between pi by 2 to pi, can you tell me, is it a possibility that dy by dx is negative in this whole range? Is it possible? Between pi by 2 to pi, your x raised to 99 is a very large value. See, it is a very, very large value because pi by 2 is a number that's greater than 1. And obviously, pi is a number that's greater than 1. So it keeps on increasing and it becomes a really large value. So your cos x, even though your cos x is a negative value, but it will not be able to cancel out this huge value. So in your second option also, your dy by dx is a positive value, right? It will be a positive value. See, I'll show you how. Between pi by 2 to pi, okay, between pi by 2 to pi, your cos x is definitely a negative value, but your x 100 times x raised to 99 is very, very large value. See, cos x is just between, see, cos x will be between 0 and -1, okay? Cos x will be only between -1 and 0, but 100 x raised to 99, pi by 2 means something like 1.5. So you take 1.5 raised to the power of 99 and multiply it by 100. So there is no chance that the sum of this can equal to be 0 or negative. So there is no chance to this. So obviously your value of dy by dx will be positive in your second option also. Let us have a look at your third option. So in your third option, you have got a number 0 to pi by 2, between 0 to pi by 2. You have got 100 x raised to 99, okay? And you have got cos x. Tell me, is your cos x positive or negative in your first quadrant?
Positive, sir.
Positive,
Cos
sir.
x is positive. What about x raised to 99? X raised to 99, is it positive or negative?
Positive only, sir.
It is positive. So is your overall sum positive or negative?
Positive.
So
Positive, sir.
obviously, yes, correct. So obviously it is increasing. So in the first interval also it is increasing. In the second interval also it is increasing. In the third also it is increasing, right? So your option will be none of the above.
Yes, sir.
Okay, right. Fine. So just one last question before going today. So you have been given a function y is equal to x square e raised to minus x. And you need to tell me what are the intervals where the function is increasing. Okay. Where this function is increasing. Let us have a look. So can you just differentiate this and tell me what will be the derivative of this thing?
2x.
2x into e raised to minus x plus x square into e raised to minus x into minus 1. Correct?
Yes, sir.
Yes, sir.
So it can be written as e raised to minus x into 2x minus x square. Fine. Okay. Correct. So 2x into x square. So e raised to minus x. What do you know about e raised to minus x?
Sir, it's always positive, sir.
Great. It is always positive. Correct. So 2x minus x square. You have got 2x minus x square. So it can be written as x into 2 minus x. So tell me, what are the crucial points?
0 and minus 2.
0 and
0
2.
and 0
2,
and 2.
Two,
Correct.
sir.
So to the right hand side of 2, is it positive or negative? Really tricky
Positive.
thing.
it is
Sure. Sure. Who can tell me? Gayatri, what do you think? To the right hand side of 2, is this thing positive or negative? X into 2 minus x. See, don't get confused. In order
positive.
to, no, it is not positive. I'll tell you why. See, this thing is x into 2 minus x. Okay. So if you remember, if you had attended wavy curvy method, so in that actually all the brackets needed to be written in this form.
Yes, sir.
Okay. You remember this? So in order to do that, you will need to take out a negative sign. So it will be something like minus x of x minus 2.
Yes, sir.
Right? So now it will start from a negative sign. So it will be something like this. So tell me, what is the interval in which the function is increasing?
From 0 to 2, sir.
Correct. See, in order to apply Wavy-Curvy method, all your brackets should be of this form. Okay. Brackets like x naught minus x or 3 minus x, 4 minus x won't work. Okay. Your bracket need to be in this form, x minus x naught. Okay. Fine. So that is it for today. And I just have one homework for you. One small question as homework. So you have got your y as the cubic equation. It's x cubed minus 3x square plus 3x minus 100. And you need to prove that this function is always increasing. Let us see how you can do it. So y is x cubed minus 3x square plus 3x minus 100. And you need to prove that this function is always increasing for all x belonging to R, real number. Fine. So that's it for today. Ma'am, can you please end the class?
Yes, sir. Yes,
Sure,
sir.
sir.
Okay, so
Thank you, sir.
just a minute, ma'am.
Sure, sir.
Students, you again have class tomorrow morning. You don't have 7:30 to 8:30 class. Directly you have morning class.
Ma'am, can I have 2 minutes? Actually, Bhavna had asked a doubt in the chat box, so only if I could clear it.
Yes,
Yeah,
sir.
please, sir.
Yeah, so so Bhavna had just a minute. She had a question. Question number 25, right? Bhavna?
Yes, sir.
25 or 26, which one? Or both?
Both, sir.
Okay, fine. So let us do 25th question because it looks okay, fine. So just a minute, I'll share my screen again. So it says that 3 times of f of x plus 2 times f of 1 by x is equal to 1 by x minus 10. Is this the question? Right? 3 times f of x plus 2 times f of 1 by x is equal to 1 by x minus 10. Correct? So if you have gone through relations and functions, so this is a clear functional equation, right? It is a functional equation. How do you solve such a functional equation? So from this functional equation, if you substitute in place of x, if you substitute 1 by x, so you will get 3f of 1 by x plus 2f of x, right, is equal to x minus 10.
Yes,
Is this
sir.
right? Right? So from these two equations, see, I have got two equations. From these two equations, if you can eliminate f of 1 by x, okay, eliminate f of 1 by x. How will you do that? Tell me, how will you eliminate f of 1 by x? So you can multiply your second equation by 2 minus the first equation by 3. When you do this, you will eliminate your f of 1 by x and you will get your final value of f of x. So you will get your f of x. And after that, you can just directly calculate f of 3 plus f dash of 1 by 4. Fine. So this is all you need to do. Anyone who did this question
I
correctly?
did, sir.
Okay, so you applied the same method,
Yes, sir.
right? Okay, Bhavna, did you get it?
Yes, sir, I did, sir.
Okay, you got the method?
Yes, sir.
Okay,
Sir,
so
but
like
it is wrong, sir.
the answer is wrong?
Yes, sir,
Okay.
I
Okay,
done.
fine. So I'll do it and get it to you tomorrow. Okay. If the answer is wrong, I'll change it. Not an issue.
Okay, sir.
Fine. Okay. Okay. Ma'am, can you please end the class?
Sure, sir.
Okay, sure. Thank you, sir.
Bye, sir. Good night, sir.
Students, again, you have class tomorrow morning, 5 to 7. Now, if you don't have any class, you please revise whatever sir has discussed.